Hello, class. Welcome back to 1.3b Exponent Properties Continued. Just to recap a few of our properties you can see below here in our form here. If we're looking at a to the m times a to the n, we are going to be adding. If we see those exponent to an exponent here, m to n, we are multiplying. We talked a little bit about the power of a product, which is going to be if you have two different things inside parentheses, we need to make sure that that m gets distributed to both terms. Any exponent that is negative really means we need to bring it to its reciprocal spot. So same would go if it was negative in the denominator, we would have to bring that back to the numerator. Anything to the 0 power is equal to 1. We talked about dividing exponents, and that really is the equivalent of subtracting. And then lastly, we took a little bit of the, a fraction to an exponent. You need to make sure that your exponent goes to both parts. All right, let's take a look at a few examples where we can apply these. Okay, looking at this first example, when we go to solve these more complex exponent problems, the first step is really just devise a plan. I like to kind of follow your normal order of operations with PEMDAS, looking first in parentheses, then towards exponents, and then kind of just working your way through. So we can look at this problem. We can see here that there's an r to the negative 5 to the negative second power. So that's to our exponent. Now, before we get too carried away with saying, well, yeah, negative exponents, that means like your reciprocal. It does, but what happens if we actually look at this and say r to the negative 5 to the negative 2? Well, a negative 5 times negative 2 is really just going to become r to the 10th. And then we're still going to have it now r to the 10th, r to the 3rd. Well, if we kind of put that little operation in, that's just the equivalent of multiply, which our rule states, make sure you add those. So add those two exponents, r to the 10 plus r to the 3rd. Our final answer is r to the 13th power. Looking at this second example, again, we want to kind of devise a little bit of a plan. If we look inside the parentheses, there's nothing that has the same base or nothing we can work with. So next thing that kind of brings us is to those exponents. Well, in these cases, this is going to be one of those ones where we need to make sure that this exponent gets distributed to all three terms. So we're going to kind of start off that first step with just saying 3 to the 6th. When you multiply, we need to add, or when we multiply exponents, we need to multiply. So that's our top half. And then if we look at the bottom, we have this negative exponent. I wouldn't worry about that yet. Let's distribute that, and then we'll kind of see where that takes us. So again, we will have some negative exponents here, and then we'll have to talk about how to handle those. So to get rid of these negative exponents, remember what that means. That really is just going to tell us that all of these negative exponents are basically in the denominator, need to come up to the numerator. So we could rewrite that 2 to the negative 2 as 2 squared. That a to the 10th. Now remember, we're kind of bringing everything up together, so that a 12th is already up there. If we want to bring that a to the 10th up, we have that b to the 24th. And then we can bring that b to the 18th up with it. Now when we look at all of these multiplication, this is going to allow us to kind of bring our work together. If we look at the a to the 12th, I'm going to start kind of skip over the 3 to the 6 times 2 squared, because what we will do is we can just use our calculators to simplify that in a second. But what we really want to end up kind of working through here is a to the 12th times a to the 10th. That allows us to add those two together. And the same thing with our b terms. What's 24 plus 18? And that will give us b to the 42. The last thing on our list is to multiply that out. 3 to the 6 times 2 squared. and we'll simplify that and make our final answer. So with that calculation, that leaves us with 2,916, a to the 22nd, b to the 42nd. Now, some of you may have looked at this problem going back up here, just a little side note, and realize that, oh, well, this is division amongst those properties. And if they're like bases, could we just say a to the 12th minus a to the 10th? Well, yeah, that's going to end up, if you just say, oh, if you can remember that 12 minus a negative, add those together. And the same thing with your b to the 24th minus a negative 18. That is a plus b to the 22nd. And then again, we'll have to kind of bring this 2 up, and still gives us that resulting 2,916. That is another acceptable way. So it really is just going to come down to what makes more sense to you. Is it going to be easier for you to subtract the negative like we did the second part, or is it going to be easier if you just bring those up to the top, make them positive, and then we can get back into the realm of adding? So either way, isn't going to take you the wrong answer. So it's just going to be a personal preference at that point. All right, time to get practice. So try practice 1.3b, and we'll check your results when you're finished. Good luck.